All right, this is the third video for section 5.2, which is congruent polygons. In this question, we want to show that the polygons are congruent. Okay, so what that phrase means is that we have to show that all the corresponding sides are congruent and all the corresponding angles are congruent. Okay. A polygon is made up of sides and angles. So we want to show that the sides are congruent, and we want to show that the angles are congruent. Okay. Right, so for question number 5, I don't know if it's just me, but I think it's easier to look at the figure this way. Okay. So we have two triangles, ABD and CBD, and we want to show that they are congruent. Okay, so I first have to show that all the sides are congruent, and I already know that a couple sides are congruent, right? This side and this side are congruent because they have the same tick mark. The two sides on the bottom are congruent because they have the same tick mark. Now, what about the third side? Okay, so these two triangles are actually drawn in such a way that they touch, or in other words, their third side is the same. Okay, and so like for, maybe I should color these triangles. Let's color them blue and pink. So for the blue triangle, it has BD as its third side. But our pink triangle also has the segment BD as its third side. They share the same segment as their third side. Okay. So because it's the same segment, that automatically makes it congruent, or the same length. Okay. A reason that we can give for this is the reflexive property. Okay. Anything is equal or congruent to itself. In this case, the segment BD is congruent to itself, right? So we can just put a congruent mark, a new congruent mark on that segment. Okay. So we've shown that all three sides are congruent to each other. Now we need to show that all three angles are congruent. Okay. We already have that angle A is congruent to angle C because they already have the red arc symbol. Okay. Let's look down here at point D. Okay. So let's just call this angle number 1 and angle number 2. Okay. Now, since angle 1 is 90 degrees, right, I can conclude that angle 2 is also 90 degrees. Okay. And what kind of justifies that is the fact that these are linear pairs, or this is a linear pair of angles, so they have to add up to 180. So I'll just write linear pairs sum to 180 degrees, right? So if I know one angle is 90, the other angle would have to be 90 as well. And so that just leaves the angle at the top of each polygon, of each triangle. And in fact, I know that these two angles are going to be congruent to each other as well. Okay, so I'm going to put a new set of marks on them, arcs, the double arcs. Okay. So how do I know that these two angles are going to be congruent? Okay. Well, I already know that my two triangles have these angles congruent, and I know that they have these angles congruent. But I also know that the third angle has to be 1 so that the angles inside each triangle add up to 180. Okay. So if I already know that two angles are alike or congruent, the third angle would also have to be the same because of the restriction that they have to add up to 180. Okay. And so this is called the third angles theorem. Okay, which basically says if two triangles already have two congruent angles, then by default, the third angle is going to be congruent as well. Okay. And so now we've shown that these triangles have 3 congruent sides, 1, 2, 3, 1, 2, 3, and they've got 3 congruent angles, 1, 2, 3, 1, 2, 3. And because all the sides are congruent and all the angles are congruent, that means the overall shape, the overall polygon is congruent as well. Okay, so let's write a statement here. So I'm going to say triangle ABD is congruent to triangle. Okay, now notice the order that I chose the letters, right? A, which is the single arced angle, and so C would be the corresponding one. And then B, which is the double arced, so B would also be the double arced angle in the pink triangle. And then D is the right angle, and D is also the right angle in the pink triangle. So ABD, CBD. So we're just, again, trying to be consistent when we name the polygons. We're doing things in the same order, okay? Single arc, double arc, right angle, single arc, double arc, right angle. The second question, or the second set of diagrams, these are quadrilaterals. And to make our life a little bit easier, I'm just gonna cut them out and turn them so that they have the same orientation. So this is how they were originally drawn, right? So we have G, H, I, J, and M, N, K, L. But obviously, if I turn that one, if I rotate it 180 degrees, right, then they look to be exactly matching. Okay. So can we show that all the sides are congruent? Well, it's already shown. Single tick, double tick, triple tick, quadruple tick, quadruple tick. Okay, so the tick marks already show us that the four sides are congruent. Now we need to show that the four angles are congruent. Okay, single arc, double arc, square, square. So these are both 90 degrees, and we know that 90-degree angles are always congruent to each other. And then square, square, again, two 90-degree angles automatically congruent. So this diagram already shows that the four sides and the four angles are already congruent. So we're just going to write a statement that says the entire polygon is on the left is congruent to the polygon on the right. Okay. I'm going to start in the top left and go clockwise around. So this will be G, H, I, J. So G, H, I, J is congruent to, and then I'm going to do the same thing, start in the top left and go clockwise around. K, L, M, N. All right, and that's all there is to those two problems.